All right, welcome back, and let's get started with our next lab, which is working with data in a Microsoft Fabric event house. In this lab, we're going to be focusing more on the event house, which is used to store real-time data and also used to query that real-time data. The data that's often stored in the event house is sent to the event house through an event stream. So we'll also be creating an event stream, but we're going to focus more on the event house. All right, this lab will take us approximately 25 minutes to complete if you do not have that much experience with Microsoft Fabric. But if you do, it should take us less amount of time. So to begin with, let's create a workspace. You can see the workspace icon right here in the menu, and we can go down and click on the plus new workspace button. Let's call this the DP-700 Lab 9 workspace, and make sure that we have the Fabric trial selected, or if you don't have access to the trial, you can also create a premium capacity or a Fabric capacity and click apply. All right. So now that we have our empty um, workspace, let's create an event house. For that, we are going to go to the real-time hub, or sorry, we're going to go to the workloads section, and then we're going to be selecting in here the real-time intelligence homepage, and we're going to select the explore a real-time sample that you can see over here. So by creating this sample, we have avoided to those steps of creating an event stream, which we would have to create to have some data in event house. So this gives us RTI sample event house with some data already created. You can see we have a table here called bike stream. And we can also look at this bike stream data, and you can see we have some data here in the bike stream table. Now let's query this data with KQL. For that, let's navigate to the query set file, which we have here. And we're going to just collapse this to get some more space on the screen. And let's modify this first query here and just say bike stream, because that's the name of our table. And we can run this query. And we can see 100 records here, for example. All right. So the pipe character you can see here, that's used to separate query operators, or it also is used as a logical OR operator. Okay. All right. Now let's copy this next query here. I'm just going to copy it at the end over here. And here we're using also the project operator, which is sort of like a select in a SQL query where you say select street and number of bikes from bike stream, limit 10. So it's basically equivalent to something like that. So we are selecting two of those columns. We do not want to see all of the columns. And then let's try this other query here. I'm just going to put it at the end here as well. And here what I'm going to do is I am actually going to sort of rename my column. So this in the square brackets is the new name of the column, and that is equal to no empty docs, for example, which is the name of my field. We can also summarize data using KQL. So I'm just going to copy this summarize code and let's look at it. So summarize here is to create an aggregation. For example, I want the sum of the number of bikes, the total number of bikes. So I can just run this and it gives me just one number. because I haven't done any group buys or to create any categories in here, but I can do that. So here, let's do it to see the number of bikes per neighborhood. So now I'm going to add a group by, which is actually done by this by neighborhood part. This is my group by neighborhood, and in the project part, I'm selecting the neighborhood and the total number of bikes, the new column that we have created. And there you go. Now I have the total number of bikes per neighborhood. All right. Here we're going to do something different where we're going to check if there is any null values or any unidentified values in the neighborhood. So let's take a look at that. So here the first part of it is the same. The summarize function, our operator is the same. The part we have changed the second option, second part, which is the project part, which is where we're checking if the neighborhood um, is a neighborhood field or column is empty or is null or unidentified, and we're just going to project that with unidentified. All right. So you can see we don't really have any nulls, so we didn't get that unidentified marker, but if we had nulls, it would have shown up as unidentified neighborhood instead. Okay. Now let's take a look at how we can sort data using KQL. So I'm going to copy this query, and in order to sort by, we have the sort by operator, which is similar to the order by operator in SQL. So the first part of it is the same as the previous code. The only thing we've added is the sort by operator at the end, which is sorting by neighborhood in an ascending order. Okay, so it's worked well for everything except West Chelsea is appearing twice, and it's not was not able to. So maybe there is some space before the W, which is why it's taking this as before B. But for the rest of the data, it looks good. All right. Okay, and let's try the order by operator as well, because we do have an order by operator as well, which works the same way as the sort. It's the exact same result. All right. Next, let's filter the data using KQL. So we have a new code here. And to filter, we use the where clause, very, very similar to SQL. And the first line here is my where clause, where I want to only see the data for Chelsea, for the neighborhood of Chelsea. So you can see now I can see only the data for the neighborhood of Chelsea. All right. We can also query the data using Transact SQL. It doesn't the KQL database doesn't support Transact SQL natively, but it does have a T-SQL endpoint that emulates the Microsoft SQL Server and allows you to run T-SQL queries directly. Okay, so let's take a look at that. We're going to add this code, for example, in our query set, and we're going to run it. And it works. It gives us the top 100 rows of data in bike stream. Let's add another one where we are selecting the top 10 and only selecting streets and number of bikes, and you have that there. And let's do this with giving another alias to a number of empty docks, and that works too. All right. We can also summarize data using T-SQL. So this is the sum function, that's total sum, total number of bikes. And then we can also group by neighborhood, for example. So this also works here, for example. And if we want to create that unidentified category for the neighborhoods. We also have the code here when neighborhood is null or is empty, then unidentified, otherwise neighborhood. And then we're selecting it and then we're grouping by that case function as well. And as you know, we do not have any nulls in here, so we do not get that unidentified category. We can also sort data using the order by function in SQL. There you go, the exact same result as we got with KQL. And we can also filter the data. As you know, if you have a group by, the filter goes in the having clause, not in the where clause. There you go. And with that, we are come to the end of our lab. Thank you for watching, and I will see you in the next one.